All right. Suppose you wanted to make $1 million. Hopefully you're on 9-6. You have 9-6 in front of you. Here we go. Suppose you wanted to make $1 million. You were starting out with $1,000. You could get somehow 12% annual interest compounded monthly. How many months would it take? So you know the formula, right? You would go n equals n naught 1 plus r to the t. And then my final amount I want to be $1 million. Initial amount's $1,000. I got 1 plus 0.12 over 12 to the t. And so, (1.01 to the t). Feeling good about myself. I know how to answer this right. Divide both sides by 1,000. I get 1,000 equals 1.01 to the t. And I'm feeling it, and now I'm stuck. Why am I stuck? I am stuck because the way we do algebra is always do the opposite. Like, for example, I divide both sides by 1,000. I divide both sides by 1,000. Okay? What is the opposite of having something to a power? So mathematicians invented something. They called it taking a log. Taking a log, or doing a logarithmic function. And so we're going to take a log. So for example, I have 49 equals 7 to the 2. Right? The question reads, to what power do I, x, sorry. Here we go. We know what it's going to be. We should get 2, right? It says, to what power do I need to raise the base of 7 to make 49? So the inverse of that function is log base 7 of 49 gives me what power? Okay? So notice what happened. The 7 swings over here, becomes part of the log. Okay? 7 swings over here, becomes part of the log. So basically I asked you, what power do I need to raise 7 to make 49? That's what a logarithmic function does. And notice what else it does. It's the opposite of raising something to a power because I lowered it. I said, to what power did you raise 7 to make 49? And we know, what power do I need to raise 7 to make 49? Well, that's obviously 2. So x is equal to 2, and there's my inverse function. Right? And so another way to look at this is 49 equals 7 to the second power. Can also be written as log base 7 of 49 is in fact 2. These are synonymous, written slightly differently. Okay? All right, so the first type of problem you're going to run into on the back of this page looks like something like this. It says, rewrite log base 9 of 18 equals 2. Ah, that's not right. Fix this. This is not right. You better fix this. See? That's why I have to be around. Otherwise, bad things happen. This should be an 81. Make that an 81. Don't make an 81. You're on your own because you're going to be confused for eternity. Okay, so how do we write this? I swing this back over here. I always pictured it as an orangutan moving back and forth. That's another way to write the same thing. Got it? All right, so you got some problems on the back. You're going to have to try this out. Okay, try out the problems. 1 through 6. And then I'll be right with you. I'll actually try problem number 1 on the back. Let's make sure you go. Well, you did problem number 1. Try number 2 on the back. And then we'll pause this and we'll wait a moment. And then when you guys have all tried number 2, we'll make sure we're doing it right. All right, so I'm ending my pause right now. Log base 2 of 16 equals 4. So 16 equals 2 to the 4th. Ta-da! That's the answer right there. Okay, finish 3 through 6. That should be easy peasy lemon squeezy. Start me up. And then try number, it doesn't even have a number on it. It says log base 5 of 125. And log base 3 of 127. And log base 9 of 27. That one's going to be really tricky. Try those 3. And I will come see you, and I'll do those problems with you in just a little bit. So do the 3 through 6, and then do those ones in the middle. See the ones in the middle? Go ahead and do the ones in the middle, and then we'll rejoin ourselves when you guys are ready. Pausing now. 3, 2, 1, pause. All right, so you should have a chance to do those other 3 problems, and Should have tried these 3 problems in the middle, which probably caused you some problems, and so we'll definitely do this in just a moment. But let's do it. So let's do those problems in the middle. I got log base 5 of 125. Agreed? So how can I write it? I'm going to put an x out here, swing it around like an orangutan. I go 125 equals 5 to the x. Now the way to do this is you go, well, if it's going to work, and I'm going to do this without a calculator, then this over here has to be related to this. So 125 is 5 to the what? 5 times 5 is 25, times 5 is 125, so 5 to the third equals 5 to the x. Now I'm going to tell you something that is not the official rule, but I call it this simply because it's the only rule that makes any sense to me. The only way to call this makes any sense. This is called the equality property of exponential and logs. Blah. We're going to call it the no-duh law. If the bottoms are the same and there's an equal sign, the tops have to be the same, therefore x equals 3. Agreed? Now that I've tried that one, give you a moment to take a look at the next one. I'm going to do log base 3 of 1 over 27. Oh, let the sweat begin. Whoops, that's not right. Not equal to. If it's equal to, that would be really hard to do. So I'm going to set equal to x. Swing it over. I get 3 to the x equals 1 over 27. Using the exact same reasoning here. I go to what power do I need to raise 3 to make 1 27th? Well, I know what 27th is. It's 1 over 3 to the third. I'm pausing there. Everybody with me? Can't check to see if you are, so I hope you are. I'm going to wait a little bit longer just to make sure. That's the person next to you if you're not with me. It's raining right now. It's probably not raining right now. Yes, this is Buddy voice. This 1 over, so we know that's just a negative power, right? So using the no-duh law. Again, don't tell your college professor it's called the no-duh law. It is not called the no-duh law. Last one is where we get to test your mathematical skills, because that's fun. I'm going to set equal to x again. I'm going 9 to the x equals 27. And now I start to sweat profusely because Mr. Resney said that some way these two are related by the same base. And I look at 27 and go 9 to the what gives me 27, and unless you are really good at this stuff, you don't have an answer. Since you don't have an answer, follow me through the answers. I go 27 is 3 to the third. And 9 is 3 to the second to the x. We know, because of the power rule, this is 3 to the 2x. Using no-duh, I get 3 equals 2x, pausing there. Oh yeah. X equals 1.5 power. Dun, dun, dun. So 9 to the 1.5 power is 27. All right, that should set you up pretty good to do number 7 through 12. Enjoy the bumpy ride. I will see you. I'll talk to you in a little bit.